Okay, the Unit 5 question is about you have one thing and you're putting it in a group and you want to know what's the probability of that group meeting some sort of predetermined kind of like set number or something, right? So a can of pumpkin pie mix contains a mean of 30 ounces and a standard deviation of 2 ounces. The contents of the cans are normally distributed. What's the probability that 4 randomly selected cans of pumpkin pie mix contain a total of more than 126 ounces? So our average pumpkin pie mix is 30 ounces with a standard deviation of 2. So basically that's true for all cans of pumpkin pie mix. It says normally distributed. It's good for us. Probability that 4 randomly selected cans. So 4, okay, right, that's your mu. That's your sigma. That's our n. So we have 4 cans. They want to know with 4 cans, will it total 126 ounces or more? So what would we expect the 4 cans to weigh? So we're going to say the average, we would expect 4 cans to be 4 times 30. That's what we would expect the average of those 4 cans to be, which is 120 ounces. Okay, the number we're trying to compare the 120 against is the 126. So it's kind of like the greater than 126, but yeah. So we need these 5 numbers: our mu, our sigma, our sample size, our average, and our x. So we're going to start those numbers. We're going to do one small calculation. Oh, one more number. We got to figure out our standard deviation of that average, okay? And we do that by taking our standard deviation of one thing, okay, like 2, and divide that by the square root of our sample size, in this case 4. So 2 divided by the square root of 4 is 2, which is like 2 over 2, which is just simply 1. All right, so what we need to do is find out a z-score, okay? We need to know if this is like 120 and we're adding a standard deviation of 1, that would mean we would expect about 68% of our values to be between 119 and 121. We go out again, okay? And we would expect it just to kind of follow this kind of path like this, okay? Now 126 is like way over here, right? How far away is that? And that's going to be our z-score, okay? How many, like if that is one z-score, right? That's 2 z-scores. How far away is it to get all the way out to 126, wherever that might be, dot, 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 okay? What's going to be that z-score? And that's going to help us with our probability. So to find my z-score, I take the number I'm looking for, that 126, take away the average of 120. Divide that by that standard deviation value, which is just 1. Okay, it's 1 for this problem. Not this 2, but we're looking at the average of all 4 should be 1. So when I do this, I get 6 over 1, which is just 6. So this would be, 1, 2, 3, 4, 5, 6 out there, which makes sense. If you're going 120 plus 1, do that 6 times, you get to 126. That makes sense with a z-score of 6. Is that my answer? No, that's my z-score, okay? So I got to go to my table and figure out where 6 is. Now there's no 6 here, right? The biggest number is 3.9. In fact, this is like a 3.99 way over here, okay? But this is for the left side shaded, okay? This is like if I went out here and said, I'm going to shade everything to the left of this line over here, okay? We don't want the left side. That's the less than. What we want is where it's the, some number in the right side shaded. We want the greater than. Okay, this table gives us the left side shaded probability. We want the left side shaded probability. Okay, we want this to be like wherever the 126 is, and we want it to be greater than the 126. Okay, more than 126. So to do that, we say 1 minus that 9999, whatever type number. And when you do that, right, it just kind of, as you see scientific notation, you're going to get like 0.0001 type numbers, okay? And so for a problem like this being so far away, the probability of getting a z-score that's greater than, or greater than 6, the more than 6, is the same as, yeah. So that's going to be we'll just say less than 0.001. Okay, it's going to be a small number. It's going to have a lot of zeros there, I believe. Okay, so how to calculate the probability of this is start by doing an inventory of what you have. They're going to give you an average. You're going to give you a standard deviation. Okay, they're going to tell you a sample size. Take that sample size times the average of one thing to get the average of the group. Okay, to do the standard deviation of the group, you take the standard deviation of the one thing and divide it by the square root of how many are in the group, so square root of 4. To find your z-score, you start with the number they want you to like use, which is like 126, okay, and then subtract the average of the 4 things, divide by the standard deviation of the group, and that gives you a z-score. You take the z-score, go to a z-table, and if it's off this table, it's usually like a really small number, less than less than 1/1000th of it. Yeah, less than 1/1000th, tiny number. Okay, so that's how you do a problem like the Unit 5 question.